So this is the talk that I gave a few weeks ago at the Erlang workshop, ECM Erlang workshop, about linking unit tests and properties. And there's a paper about it with Alex and Nick Smallbone and Meng Wang. So we all know that the Quickcheck mantra, don't write tests, generate them. So suppose that a customer comes along and says, here's my API. I've implemented a sets module, and here are the operations. Why don't you generate me some tests for it? So what do we got? Well, we can create an empty set, we can add an element, we can delete an element, and we can ask how many elements are in the set. A very tiny API, but it's just an example. So we know what to do, right? We would get our state machines module, and we'd generate API call sequences, and define a model state and model state transitions, and write post conditions, and so on. Everything's fine. Let's look at a couple of fragments of a spec that we might write for this. So we need to model the state of the set. Let's just use the list of elements. You can start off with an empty list. And then we need to model the state transitions. So for example, here's how I might model the state transition of adding an element to a set. We'll just take the previous value and the element and just append it to the end. And here's the specification of size. Size doesn't affect the state of the set, but it's just going to check that size returns the number of elements, the length of that list. Okay, so we can build our specification like this, and then we can run the tests. Here we are. I've run 10,000 of them, and look, we ran 10,000 tests. Wonderful. But what if the customer says, what about this one? We ran 10,000 tests. But what about this one? So what's the correct answer? It's obviously, why do you want to know that? But wait, maybe the customer has a good reason. Let's not forget, the customer is always right. And sometimes customers ask this kind of question. So, you know, why do you want to know doesn't always cut it. But there are other reasons why you might want to ask this kind of question. You might be a developer and you might have a unit test in your code. Can you delete that now that you've got the Quickcheck spec? Or do you need to keep it because it's testing something fundamentally different? Or you might be working on developing your Quickcheck test suite, and you might wonder what kind of things you're testing. And one of the questions you might like to ask is, you know, I wonder what kind of tests I'm generating. Can I generate this one? So, it's not necessarily a bad question. So let's see if we can answer it. Did we test that? Well, I didn't show you the argument generator for add. Here it is. We pick a number between 1 and 10,000. So probably we didn't test that then. We've got a 1 in 100 million chance of picking 42 twice. And in addition, we would need to generate this sequence of calls. So we probably didn't test it. But luckily, what the customer means is not, did you test this? But can you test this? Or if I'm considering deleting the unit test from my test suite, I don't necessarily want to know that it'll be generated every time I run Quickcheck, but I'd like to know, can it be generated by Quickcheck? And this is what I'm talking about. We have a prototype tool that can answer this kind of question. Okay, so what do? In order to ask, can we run this test? The first thing we do is construct a symbolic representation of it, and this is the usual Quickcheck symbolic representation. And, well, suppose we then test it. Here's what happens. We run check, we run the test, and oh dear, it fails. So that tells us that we did not test it. And if we had done, we would have found a problem. Now, in fact, in this case, when I add 42 twice, there's only one element in the set. So the code is returning the right result here. It's the model that is wrong. Why is that? Because I have a bad model. For a start, I chose arguments in the range 1 to 10,000. Why on earth would I do that? It makes it almost certain that I won't choose the same value twice. Secondly, look at my state transition. I just add the element to the list, regardless of whether or not it's already there. It's rubbish, but this is not the point today. So let's not worry that the model is bad, and let's focus on answering the question, can we generate this test? Well, so we just ask, possible? And it says, after a short time, yes, we can. Okay, great. So how can we answer a question like this? Can we generate this test case? Well, this question is a very hard question to answer because this test comes from an enormous space of possible tests. But luckily, we can reduce the problem like this. We ask, here's the first command, can we generate this in the initial state? After one command, we're in this state. We've got an empty list of things in the set. Now, can we generate this command? Okay, then we've got 42 in the set. Can we generate this command? And so on. So we can step through the test case and figure out the whole time what model state we're in. And then we ask the question, can we generate the next command in this state? And that is a much easier question to answer.
Can you answer the probability of generating that test as well?
We're answering questions like this. Can choose 1 to 10,000 generate 42? Well, here's how we can find out. Just try it really many times. And then one or two things happens. If we got 42, the answer is yes, it can. If we didn't get 42, the answer is probably not. So we can say that we can't say no, we definitely can't generate 42, but we can say the probability of generating 42 is actually less than 1 in 2,000. And this number is about a fifth of the number of times we try. Now, in this case, the model is so bad that I would really need to try more than 10,000 times to be able to be reasonably certain that we would end up taking this path rather than this one. But even with this very bad model, and even with only 10,000 attempts here, which, by the way, happen very quickly, then I get the right answer most of the time. So that call I showed you, it returns true most of the time. Okay, so we combine the idea of checking one command at a time with the idea of just repeating generation of a command enough times until we see if we get the one we want. There's one more thing that we need to add, well, a couple more things. One of them is the test case that the user asked us about includes an assertion. So do we check the assertion? So this isn't a question of whether we can generate this test case or not. It's a question of whether we check that the result of size is equal to 1. And that means, does the post condition that the model contain imply this assertion that the user wants tested? Because if not, then we're not doing as strong a test as the user is asking about. So, to answer this question, we have to tell the probably tool, or the possibly tool, about the assertion. So, in this case, I've just added assert equals var4, the result of size, and 1 as an extra component to the test case. This is what you do with the current version of the tool. Okay, and then if we test that, it says, no, we can't generate this test case, or we can't generate the assertion, because the assertion that v4 equals to 1 fails for v equal to 2. What this means is that the post condition accepts the value 2, whereas for which the assertion fails.
So you are testing the implication here.
Yes, we're testing whether the postcondition implies the assertion. And of course, we have to check that for a particular value. Well, we can check it for the actual result that size returns, but in this case, that's not the one of interest. What we want to check it for is all of the possibly wrong results that size might return. Right? Because the interesting case here, the case that shows that we're not performing this unit test, is the case in which size returns a wrong result and the postcondition doesn't notice. And that's the bad case, when a wrong result is accepted by the postcondition but rejected by the assertion.
So I would say that the converse case is also interesting because then it means you have...
It means that the unit test is weaker than the Quickcheck model. Yes, but yes, I suppose that might also be interesting, but we know unit tests are weak. So we're using Quickcheck to generate a variety of possible wrong results here and try them out. So there's one more wrinkle, and that is, in this test case that the customer asked about, we've got this 42. Right, but 42, the value 42, actually isn't important here. What's important about this test is that we use the same value twice. Now, this is something that I might surmise by looking at the test case. Of course, in reality, before assuming that this value doesn't matter, one should consult with the domain expert, just to be sure. But if what we mean here is, have we tested with two equal values, then we want to allow arbitrary values other than 42 when we're generating the tests. And we can do that too. That's what this say 42 says. Okay, so this is like a bound variable in the test. So we're going to say we can generate this test case if we can get any value at all here. But because we have a 42 here, whatever value we match here must also match any other occurrences of 42 in the same test case. So it's maybe slightly funny syntax. It's like putting the same variable in these two places. And it could be 42. If we want to just run this test, we have a possible value there, but we'll accept any value as matching it.
So why did you choose for this instead of, say, var x on two places? Is it because you want to have the time? Or?
I have co-authors on this paper.
Oh, I asked them instead.
Yes. Yes, so what this does, of course, is it speeds up very much the second step when we're asking, can we generate this command? All we have to ask is, can we generate any add command? It does not speed up finding the third one. There we really have to generate the same value that we generated the previous time. But still, it'll make this maybe almost twice as fast. Okay, so that's what the tool does. It's quite simple. Does it scale up? So of course, whenever we want to know whether anything scales, we try applying it to out-of-SAR tests. And I don't know if you haven't seen this, at Cubic we did a lot of work over the last few years at testing out-of-SAR code, basically the operating system code that runs on the processors in cars. And that consists of things like an Ethernet stack, the CAN bus stack. These are all protocol stacks. This is some routing stuff. This tracks the fault codes when your car misfires on one cylinder or something, and it tells the service station when you take it in for repair. We tried out this new prototype on the CAN bus stack, and that is 4,100 lines of Quickcheck model, never mind the implementations. So there's quite a lot of code there. It's quite a big API. And then we needed some tests for the CAN stack, some unit tests, so that we could ask, can our Quickcheck models generate these unit tests. So where would we get unit tests from? Well, it turns out that the AutoSAR consortium has created some unit tests for the CAN bus stack. And in our format, here is one. Got that?
Is that the single test?
Yes. This is a single test case. And look, it's got some arbitrary binaries in here. Can you imagine what the probability would be of picking that particular binary? It would be
exactly 1, because that's the first binary you get from the standard generator. Yeah, sure. Where do you think I got it from?
So here is the unit test re-expressed in Quickcheck format, actually without the set vars, but never mind. So how did it go? So there are 6 unit tests that have been constructed by the consortium for the CAN bus stack.
Yeah, the entire 6.
Yes. Well, they're not short.
Yeah.
Each test tests quite a lot of stuff.
It's distribute time for me personally.
Is what?
This is distribute time for me personally. We only have 5 unit tests.
Okay.
The very smart ones.
Smart ones. Yeah.
So of these 6, we found that 3 of them contained incorrect assertions. So Hans had to fix the assertions, and having done so,
But this means basically 3 of those tests. If you would pass those tests, your implementation would be wrong.
yeah. So then the tool says 5 of them can be generated by the model, 1 could not. So what about the one that could not? Well, we had been very careful to avoid testing some ill-defined behavior. But that last unit test just goes ahead and tests it anyway. So
What is ill-defined behavior?
my understanding is that you can't tell from the standard what should happen.
So is it like undefined behavior in C?
I don't think it's anything like so formal. I think it's just
I remember from one of your talks about AutoSARs that we found 100 errors in the spec itself.
Yeah.
So
This might be.
so one of those when
Yes.
the spec says something on one page and contradicts itself on the second page. Yes.
anyway. So this is pretty good, right? So yeah.
More and more scared of going outside.
We go for environmental friendly people.
So this was nice. So I think this showed that the tool scaled well, at least for this example. So there we are. We could use Quickcheck models now to test and debug other unit tests. Yeah. And well, this isn't really rocket science, but it works. Thank you.